Hi, these are the solutions for the 6.8.5 homework. If you have not done this homework yet, then please stop the video, go do the homework, check the answers. They are on the last page of the homework. Then if you had questions on them, then come back and watch this video, and you can fast forward to the particular questions that you need, and you don't have to watch the whole thing. I've already gone through and drawn the diagrams. I haven't labeled the diagrams, but I have drawn them. So here's the first one. Find the length of a side of a rhombus whose diagonals measure 12 and 16 millimeters. Rhombus, diagonals drawn in, and we recall that the diagonals of a rhombus are perpendicular and they bisect each other. So if this diagonal is 12, then half of it is 6. This diagonal is 16. Half of that one then is 8. Recognizing that we have a right triangle here, we can go ahead and divide by 2, which gives us 3 here, 4. That's a triple, a 3, 4, 5. Multiplying back by 2 gives us 10 out here. And that is exactly what we're looking for. The length of a side of that rhombus is 10 centimeters. Look at the next one. The diagonals of a rhombus measure 16 yards and 30 yards. Again, very similar to the previous one. 16 yards. We know the diagonals cut each other in half, so this one has to be an 8. 30 yards, the entire thing, so half of it would be 15. That sets up very nicely. This is an 8, 15, 17 right triangle right here. This time, though, we want the perimeter of the rhombus. Perimeter is all 4 sides added up here, so we have 17 times 4, which is 68. And perimeter is a linear measurement, so that's yards. 68 yards here for the perimeter. Looking at number 3, find the measure of the diagonal of a rectangle whose sides are 14 and 48. So we're going to put a 14 here, 48. We know that this is a rectangle, so we have a right triangle here. 14 and 48, if we divide both of those by 2, that's going to give us a 7 here, a 24 there. This is a triple, 7, 24, 25, but that's an inside number. We'll need to multiply back by 2 to get the whole diagonal to be 50. Number 4, the perimeter of a square is 20. Well, if we have a square and perimeter is 20, all 4 sides are congruent. That means each side is 20 divided by 4, which would be 5. And looking at this is a square, we know we have a right angle here, and those are congruent, so we have a 45, 45, 90 right triangle. Legs here, going from a leg to the hypotenuse, getting longer, so we multiply by the square root of 2. That diagonal then is 5 square root 2 inches. Looking at number 5. Rectangle has a diagonal of length 10 and one side of length 6. So 10 here, 6 here, right triangle. Again, we divide out by 2, gives us a 3 and a 5. Oh boy. We think it might be a triple, but actually it's not, because that 5 should be on the hypotenuse. So this is where we have to make up a dummy variable for that inside. So we can use Pythagorean theorem on those inside numbers. 3 squared plus 5 squared equals y squared. Leg squared plus leg squared equals hypotenuse squared. That gives us 9 plus 25 is y squared. Y squared is 9 and 25, 34. Y is the square root of 34. That does not simplify. Oops. That's okay. I realize I just made a goof mistake. I'm not going to start the video and redo it, so we'll fix the problem, and some of you are probably panicking if you're watching this. I misread this. I thought it had sides of 10 and 6, but it doesn't. It's a diagonal of 10 and 6. Let me see if I can find my whiteout. Here it is. I'm so sorry. So actually it does end up being a triple then, because this diagonal is 10, and when we divided that by 2, that is a 5, so 3, this is a 4. Sorry about that, you guys. Multiply back by 2, there's 8, and the perimeter, add up all 4 sides, we have a 6, 6 over here on this side, 8 on the top. So 6 plus 8 plus 6 plus 8. Here's 14 plus 14. 28 meters. Looking at the next one, in an isosceles trapezoid, the lengths of the bases are 14 inches and 30 inches. Bases are the parallel sides. So 14 here, all of that down there is 30, and the length of each of the non-parallel sides is 10. 10 here, 10 here. Find the length of an altitude of the trapezoid. All right, an altitude is this piece right here. That's what we're looking for. Altitude over here. All right, this is an isosceles triangle, or isosceles trapezoid. So this 14 piece that's up here, that comes straight down. There's 14 sitting right there. 30 on the whole thing, minus this 14 in the middle. 30 minus 14, 16. That 16 then has to be split evenly between here and here, which means this piece is 8, and that piece is 8. Now, looking at this triangle, we have an 8 and a 10. We can divide out by a 2. That's a 4 and a 5. That does leave a 3 here. And when we multiply back by 2, that does get us to this altitude of 6. And that altitude is 6 inches then. In our equilateral triangle, because it's equilateral, all of the angles are 60. I'm not drawing this one up here because it's telling us that we want an altitude. So I'm going to draw that altitude in. That altitude is right there. That gives us a 30, 60, 90 right triangle. That altitude is 14 square root 3. That's the long leg on this 30, 60, 90 triangle over here. To get from the long leg back to the short leg, getting shorter, so we're going to divide by the square root of 3. There's 14. Then this side, is that short leg times 2, which is 28. And perimeter then, 3 sides, each at 28. 3 times 20 is 60, 3 times 8 is 24, so 84 feet. Next one, diagonal of a rectangle whose sides are 20 and 48. Okay, I'm reading carefully here. Sides are 20 and 48. So 20 here, 48 here. We can divide by 4 this time, gives us a 5 and a 12. 5, 12, 13. But then I have to multiply back by 4, and 13 times 4 is 52. So that diagonal is 52. Now, this problem did not have units on it, and our general rule in math is if there are units in the problem, then you write units on your answer. But if there are no units in the problem, then don't worry about units in your answer. Number 9, find the perimeter of an isosceles triangle whose base is 16 decimeters and his height is 15 decimeters. Isosceles triangle, so these two are congruent. Height in an isosceles triangle runs right down through the middle. There's your height. Base is 16. Height 15. In an isosceles triangle, that altitude or height does bisect this base. It doesn't happen in every triangle. It does happen in an isosceles. So if this whole thing was 16, that's 8. We have an 8, 15, 17. We did not have to multiply by anything or divide by anything here, so we don't have to multiply back or divide back. That is just 17. Perimeter, these two are congruent, so we have a 17, and then a 16 on the bottom. (34) and 16 is 50 decimeters. Okay, next page. If at any time I'm going too fast through this, please feel free to pause the video, run it back, play it again. Number 10, find the length of the upper base of this isosceles trapezoid. That's what we're looking for. Okay, so let's see what we can do. Let's see, we have a 12 here and a 15. Let's divide by 3, which will give us a 4 and a 5. Oh, nice. That means that this piece is a 3. Multiply back by, let's see, we divided by 3. So multiply back by 3 makes this 9. Because this is isosceles, then this piece over here is also 9. Together, this piece and this piece, that's 18. 9 and 9 is 18. So the full length was 35. If we do 35 minus that 18, that's going to leave us 17 for the middle section. And then that is that upper base, 17. All right. RHOM is a rhombus with diagonals RO 48 and HM is 14. Find the perimeter. All right, remember, we started these in the beginning. Rhombus diagonals are perpendicular and they bisect each other. So RO 48 means the whole thing is 48, so half of it would be 24. HM 14, for the whole thing, half of it makes 7. This is then a 7, 24, 25, and the perimeter is 4 sides times 25 each, or 100. and no units on here, so perimeter is just 100. Number 12, altitude of the trapezoid with sides 2, 41, 20. Oh my goodness, they gave us all these sides. Okay, well, let's see if we can figure this out. 2 of the sides are congruent, the 41s. Those must be these guys over here, because the bases can't be congruent. Clearly, one of them is longer than the other one. The 2 has to be up on the top, 20 down here on the bottom, and we want to find the altitude. So I'm going to drop the altitude down here and one over here. That means we have 2 in the middle, 20 for the whole thing, minus 2 in the middle, leaves 18. Because it's isosceles, it splits evenly. That makes this 9 and a 9. Oh, and there's our triple again. This is a 9, 40, 41. So that altitude is 40. Okay, last one. One of the angles in a rhombus is 60 degrees. The perimeter is 24. Find the length of each diagonal. Okay, so we got to look at the whole rhombus first without the diagonals drawn in. One of these angles is 60. Couldn't be this whole big one because that would have been obtuse. So let's look at this whole big angle as 60. Diagonals bisect those angles, makes this a 30 then. 60 divided by 2. Diagonals are perpendicular. Perimeter is 24. 24 divided by 4 means 6 on each side. This is a 30, 60, 90. That 6 is on the hypotenuse. On the hypotenuse, to get back to the short leg. Short leg is opposite the 30. From the hypotenuse back to the short leg, we divide by 2. Makes this a 3. And then short leg to the long leg. This short leg to the long leg, we're getting bigger, so we have to multiply. And we'll multiply by square root 3. Makes this one square root 3. Whole diagonal then. This whole diagonal is 6. This one's 6, and this one was a 3 square root 3, and another 3 square root 3. That's 6 square root 3. If you have further questions on this homework, please send me an email, and I will respond to you so that we can straighten this out through this e-learning phase that we are in right now. Thank you.